Hey there, students. Mr. Harrison from school here to walk you through our slideshow on acids, bases, and then also neutralization, which has everything to do with acids and bases. So we've got chemistry. Let's get cracking. Acid is defined as a substance that produces hydrogen ions when it's in a water solution. So with both acids and bases, it has to do with what's produced in water, and also it has to do with the element hydrogen. So an acid produces hydrogen ions, which are H plus in a water solution. And later on, when we talk about the atomic structure, you'll see that H plus is going to be a hydrogen atom that is missing an electron. So that's why it has a positive charge, because electrons are negative. So if you're missing a negative, then you have a positive charge. And after the positive hydrogen ions disperse in water from an acid, they interact with the water, which is H2O. Most of you already know that. This looks kind of like H2O, but a little different. The only difference is it has a positive sign and it has three H's. So what happens is this one H plus, this positive hydrogen ion, joins with H2O to form hydronium, which is H3O plus. You got an extra hydrogen and it's positive now. So here's what you got to know. The properties of an acid are pretty predictable. The first one is that they have a sour taste. So think of foods that you've eaten that are sour. Here's a couple examples. You've got lemon juice, even vinegar. If you've eaten anything with vinegar, it's pretty sour tasting. It's because both of those are acids. And citric acid is actually the acid that's in citrus fruits. That's why they call it citric acid. So they're sour tasting. As a general rule, if you're wondering if something is an acid or a base, you should absolutely not taste it unless you know exactly what it is, because it might taste sour, but it might be very, very dangerous to taste. Second property of an acid is that acids are corrosive, which means they tend to break down things, specifically metals. Then they also, that goes to the next point, they react strongly with metals while they are corroding the metal. And if you have litmus paper, which is this stuff down here, it's going to turn your litmus paper red. And pretty much all of the time, not all of the time, but most of the time at least, acids will start with H for hydrogen as the first element in the chemical formula, because they have to have a hydrogen in them to give off a hydrogen ion in water. Another example here, hydrochloric acid, that's actually, a pretty corrosive, pretty reactive acid. So that's why it's got the danger sign next to it. Moving on to bases. A base is defined as a substance that forms a hydroxide ion in water solutions. What that is OH minus charge. That means it has an extra electron, an extra negative electron. It would look like this, okay? And it's going to have one oxygen atom and one hydrogen atom bonded together. So the little one's the hydrogen, the big one's the oxygen. Another way to look at it would be that a base is any substance that accepts a hydrogen from an acid. See, acids and bases can go together in a way, and we'll talk about that as we move on. The properties of bases that you should know is they feel slippery, especially in a solution. They are corrosive, just like acids are corrosive. And instead of tasting sour like an acid, they taste bitter. Again, don't taste them unless you know what they are, but they taste bitter. And when they are put in contact with litmus paper, they turn the litmus paper blue instead of red. So bases dissociate into a positive ion and a negative hydroxide OH minus ion in water, which kind of goes with what that last slide was saying. But there's a positive ion that splits apart from the negative OH, which is called hydroxide. Then we've got pH. You notice another H right here. It's because it all has to do with hydrogen. pH you've probably heard of, but it's the measure of the concentration of hydrogen ions or positive hydrogen ions in a solution. That's pH, and it stands for potential for hydrogen. The pH scale, it measures how acidic or how basic something is. So up here, All of these reddish orangish colors, those are all acids. Then you've got pH 7, which is neutral, and then you've got everything in the green, blue, purple, violet range. That's bases. And the range goes from 0 to 14. 0 would be very, very acidic. 14 would be very, very basic. So anything with a pH lower than 7, so 0 all the way up to 6.9 is an acid. And anything with a pH higher than 7, so 7.1 all the way up to 14, is a base. And a solution with a pure pH of 7, right in the middle, like deionized water or distilled water, is called neutral. It's not an acid or a base. It's right in the middle, very stable. So we've got all the acids, 0 to 6.9. pH 7, perfect pH 7 would be considered neutral. And then you got 8 or 7.1 all the way up to 14. This doesn't go up to 14, but all the way up to 14 would be basic. So what happens when an acid and a base react with one another? Well, when they react with one another, a process called neutralization occurs. So if you think about it like on the pH scale, if you got something really far from 7, like a 1, and it reacts with like a 13, they're kind of going to balance each other out, right? Because part of what a base is something that will accept a hydrogen from an acid. So what happens is the base and the acid chemically react, and you know that phrase, chemically react together, and it causes neutralization to occur. The resulting solution from neutralization reaction is going to be closer to pH 7 neutral because the H plus ions in the acid and the OH minus ions in the base combine to form something that's going to have, so this has got one H here and another H here with an O. If we have HOH, another way to write that would be two H's, H2O, which as you know is water. And water is pH neutral. So it only makes sense that if the H plus and another H with an O attached to it react together, the plus and the minus are going to neutralize each other. So there's not going to be an electrical charge. And the H plus and the OH are going to form H2O, which is water, and water's pH neutral. So no duh, it's going to be closer to neutral. It creates something that's perfect neutral. The last thing that's created, or not created, but formed when a neutralization happens between a chemical reaction from an acid and a base, you've got a pH closer to 7, you've got water being created, and you've got a salt being formed. So the most common type of salt in terms of in your minds is probably going to be sodium chloride, which is table salt. But there's many, many different types of salts that can form. And the positive ion, remember we said that the acid creates a positive ion and the negative ion and the base are going to neutralize each other. Well, there's also usually what's called a precipitate, which is a solid that is going to sink to the bottom of that solution. And that is a salt. It's not anything that was there before. It's not the original substances. It's a new substance that sinks to the bottom. So just to recap, neutralization reactions will result in three things. Number one, a chemical reaction. That number two produces a pH closer to 7. And then the products of that reaction are water and a salt. All right, now shifting gears just a little bit. We had mentioned before a solution is a pure substance when something combines two things together in a uniform mixture that can't be it's like dissolved into something. That's called a solution. And the rate at which something dissolves is called solubility, or the ability to dissolve. And it can change depending on many factors. Stirring will speed up solubility. More surface area or smaller particle size will increase solubility. And if you increase the temperature, you'll increase solubility. So if you ever made or had been around somebody who's trying to make homemade sweet tea and they like boil their black tea and they want to add some sugar, you should do that while it's warm because it will dissolve much, much quicker. All right, so solubility is the maximum amount of a solute that can be dissolved in a given amount of solvent. Remember, the solute is the thing that's being dissolved, and the solvent is usually water, but it's the thing that's dissolving something else. So the maximum amount of that solute, so if you got sugar water, the maximum amount of sugar that could be dissolved in the water at a given temperature is called solubility. and various substances have very different solubility rates. So the last term you need to know is concentration. And that doesn't mean just to focus. Concentration describes the percentage of a solute contained in the whole solution. So like out of the total amount of solution, what is the percentage of the solute, which is the thing that's being dissolved in the other thing? All right. And then lastly, a saturated solution contains all of the solute that it can hold at a temperature. An unsaturated solution can still hold more solute at its current temperature. And a supersaturated solution actually was saturated at a higher temperature than cooled. So it's unstable and the solute can very quickly come out. Like you can, if you cool it down, it will stay dissolved, but very, very unstable. Like if you tap the side of the container, it might turn into solid again. It's pretty cool. We may have a video I can find to show you. I'll see if I can find that. But saturated, unsaturated, and supersaturated solutions are a couple things you need to know about. All right. Good job listening. You are now free to move on to the next module post. Good luck.